Hello everyone, in this video I want to show you how you can use a classical machine learning algorithm like support vector machine on Scikit-Learn by using GPU. As you know, Scikit-Learn by default use of CPU, but I want to use GPU, and at the end of this video you can see how time it takes to do a project workflow on CPU and on GPU, and you can compare this together. Okay, for this project I want to use a very large data set that I find a data set celeb faces. It has more than 200,000 images of celebrities with 40 binary attribute annotations, and I use this data set, and Scikit-Learn I do all the workflow on GPU and on CPU too, and I compare the time that it takes on CPU and on GPU. Okay, start. Okay, in here, at first as you can see with these codes, I get the dataset from Kaggle website, and now this is the only things that we need to install to use GPU for Scikit-Learn. Okay, as you can see here, I install CodeTipsAcademy-cu12, and I say that it must be downloaded from this website from NVIDIA. Okay, as you can see, I download this package for doing a project on GPU. Now, some needed other packages: pandas, matplotlib, and pillow. At first I run the project on CPU. This is the CPU version of the project. As you can see here, the default, I didn't use GPU here. I didn't use any class in this package. I didn't use this package now. At first I only use CPU. I getting the attribute, and as you know, syllabi datasets has more than 200,000 images with many targets. As you can see here, we can define many project for example, it shows that if a celebrity is male or female, or it has eyeglasses or not. The only target that I want to use is smiling. I want to check if, for example, a face of a person has a smile on it or not, if this person is smiling or not. Okay, this is our target attribute here, and this is the images, and you can see here I don't want to go deep for the algorithm. I suppose that you know the algorithm and you know the Scikit-Learn. I only want to show you the CPU and GPU comparison. As you can see here, it has more than 4,000 features, but it's very hard. It's very a very great amount of features. I do PC on that, and to get the 200 features. Okay, after PC I get 200 I find 200 features from 4,000 features, and now after that I use support vector machine to do the classification if a person is smiling or not. And you can see here that the report, this is the evaluation that you have. I sent, as you can see, F1 score. We have a very good evaluation here. It shows that algorithm works very fine, very good, great accuracy, great F1 score. It's very good. And you can see that some results here, for example, it's not smiling, or prediction and true is it's not smiling, or here it's smiling, or prediction and true fact is smiling, and many other projects, many other faces. You can see that many of them are predicted true. This is wrong and this is wrong. Okay, but the most important part that I want to show you is here. You can see that it takes more than 6 hours to do classification for finding smiling people on the dataset. Our dataset is very large with more than 200,000, as you can see, more than 200,000 images, and it takes more than 6 hours to classify if people is smiling or not. But now I want to do this by using GPU and Scikit-Learn. Now installing this package can help us. Okay, see that. This is the CPU version. Okay, I put here to, it shows me the time, and the only difference is here. All the code is the same. The only difference is here. I use PCA for using PCA. I use this library, and for use support vector machine, I use this library too. I use cuML, cuML library for PCA and support vector machine. These two algorithms. All the code is the same. I changed this to, okay, for PCA I use GPU PCA. For better understanding, I label it GPU PCA and I label it GPU SVC for support vector machine. All the code is the same, but here you can see here that I use GPU CTA with to get that components, that agent vectors that we had before, and also I use GPU support vector machine. Now I do classification and get the same result in evaluation metric. You can see here the same result, you can see here, and also this is also wrong here. This is right. Prediction and true fact is the same, and also here this is right too. But the most important part is here. You can see here 20 minutes. Amazing. 20 minutes here. As you can see here, the CPU version was 6 hours, more than 6 hours, but the GPU version only takes 20 minutes. What it means? It means more than 19 times faster. And you can see here that by only a little change to the code, the same Scikit-Learn code, only a little change, installing this package and import the algorithm from the installed package, the new package that is installed. The algorithm use support vector machine and PCA from the new cuML package that I installed. Only that's enough. I use this support vector machine and PCA and GPU version of the code, and it speed up the support vector machine with the same evaluation metric, with the same F1 score, with the same accuracy, but 19 times faster, more than 19 times faster. It changed 6 hours and 26 minutes to 20 minutes, and amazing. Okay, if you didn't subscribe to my channel until now, please subscribe that. I want to create more amazing video for you. Have a nice time. Subscribe. Bye bye. Don't forget to like this video. Have a nice time. Bye bye.